In 1943, a farmer in rural Pennsylvania needed to replace his fence posts. The hardware store had nothing. Creosote was reserved for military railroads. Commercial preservatives had vanished from shelves. So he did what his grandfather had taught him. He charred each post over an open fire, brushed them with linseed oil, and set them in the ground. Those fence posts are still standing today. 80 years later, no rot, no insect damage, no replacement needed. Meanwhile, pressure-treated lumber from the 1990s is already failing across America. Posts installed 20 years ago are crumbling. Decks built in 2000 are being torn down. The modern wood preservation industry promised better results through chemistry. They delivered planned obsolescence instead. Here are 7 World War II wood preservation methods that still outperform anything you can buy at the hardware store today. Number 1. Charring show, sugiban. The Japanese discovered this technique centuries ago, but American farmers during World War II independently rediscovered it out of necessity. When you cannot buy preservatives, you make your own. Fire was free. Charring works through carbonization. When you burn the outer layer of wood to a depth of approximately 1/8 inch, you create a carbon barrier that is chemically inert. Fungi cannot digest carbon. Insects cannot penetrate it. Water beads off rather than soaking in. The charred layer essentially becomes a permanent coating that never needs reaction. The science is straightforward. The carbon layer has no nutrients for decay organisms to consume. It creates a physical barrier against moisture penetration. The slight texture actually helps water run off rather than pooling on the surface. Application requires only fire and patience. Use a propane torch or open flame. Burn each surface until the wood develops a consistent black layer, approximately 1/8 inch deep. You want alligator skin texture? Brush off loose char with a stiff brush after cooling. Fence posts charred using this method in the 1940s are documented surviving into the 2020s. Japanese structures treated with this technique have lasted over 300 years. Modern cost is essentially zero. You need fire and time. The results outlast any commercial product by decades. Number 2. Boiled linseed oil. European woodworkers have used boiled linseed oil for over 500 years. During World War II, American farmers applied it to everything from barn timbers to tool handles when commercial preservatives disappeared. Boiled linseed oil works through polymerization. When exposed to oxygen, the oil undergoes a chemical reaction that transforms it from a liquid into a flexible solid. This solid penetrates deep into wood fibers and hardens within them, creating a barrier from the inside rather than sitting on the surface. The penetration depth distinguishes this method from modern coatings. While paint and modern sealers sit on top of wood, linseed oil soaks into the cellular structure. It bonds with the wood itself. This means the protection cannot peel, flake, or chip like surface coatings do. Application is simple but requires patience. Warm the oil slightly to improve penetration. Apply generously with a brush or rag. Let it soak for 20 to 30 minutes. Wipe off excess. Repeat after 24 hours. 3 coats provide optimal protection. For ground contact with like fence posts, apply additional coats to the buried section. Some World War II-era farmers mixed boiled linseed oil with turpentine at a ratio of 2 parts oil to 1 part turpentine for deeper penetration. Properly applied boiled linseed oil provides 40 to 60 years of rot protection. Reapplication every 10 to 15 years on exposed surfaces extends this indefinitely. Number 3. Used motor oil. This method sounds crude, and it is. World War II-era farmers were not concerned with aesthetics. They needed fence posts to last, and used motor oil was free. The petroleum compounds in motor oil penetrate wood fibers and create a water-resistant barrier. The oil also contains trace amounts of naturally occurring fungicidal compounds that accumulated during engine operation. These compounds inhibit fungal growth even at low concentrations. The application method from the 1940s was straightforward. Farmers collected used motor oil in drums. They heated it slightly over a fire to reduce viscosity. Then they submerged fence post ends in the warm oil for 24 to 48 hours. The wood absorbed oil through capillary action, sometimes penetrating several inches into the end grain. Posts treated this way from the 1940s are documented surviving into the 2000s. 60-plus years of rot resistance from a free material. Modern considerations require honesty. Used motor oil contains compounds that can contaminate soil. Modern regulations restrict this application in many areas. However, for non-agricultural applications like utility poles, fence posts along property lines, or structures away from gardens, this method remains effective. The cost is essentially zero if you change your own oil. The protection rivals commercial pressure treatment at a fraction of the environmental impact of copper-based preservatives. Number 4. Lime wash, whitewash. Lime wash is ancient. The Egyptians used it. The Romans perfected it. American farmers during World War II continued a tradition stretching back thousands of years. Lime wash works through chemistry. Calcium hydroxide creates a highly alkaline environment on the wood surface. Most decay fungi cannot survive in alkaline conditions. The pH level of properly applied lime wash exceeds 12, which is hostile to virtually all wood-destroying organisms. The protective mechanism continues working for decades. As lime wash cures, it absorbs carbon dioxide from the air and converts to calcium carbonate. This is essentially limestone forming on your wood surface. It becomes harder and more durable over time rather than breaking down. Traditional whitewash recipes from World War II agricultural bulletins call for hydrated lime mixed with water to a paint-like consistency. The ratio is approximately 1 pound of hydrated lime per gallon of water. Some recipes added salt at 1 pound per 5 gallons to improve adhesion and durability. Application requires a large brush and multiple thin coats. Apply the first coat thinly. Let it dry for 24 hours. Apply a second coat. 3 to 4 coats provide optimal protection. The distinctive white appearance also reflects ultraviolet radiation, reducing sun damage. Barn timbers whitewashed in the 1940s are still protected today. The method costs pennies per square foot and provides 50+ years of protection with periodic reapplication. Number 5. Borax solution. Borax appeared in household and agricultural use long before World War II, but wartime rationing drove farmers to rediscover its wood-preserving properties. When commercial fungicides vanished, borax remained available because it had multiple household uses. Borax works as both a fungicide and an insecticide. The boron compounds are toxic to fungi and wood-boring insects, but relatively safe for mammals. The mechanism involves disrupting cellular metabolism in organisms that attempt to colonize treated wood. The application method from World War II agricultural bulletins is precise. Dissolve 1 pound of borax in 1 gallon of hot water. Apply this solution generously to all wood surfaces using a brush or sprayer. The borax crystallizes within the wood fibers as moisture evaporates. These crystals provide long-term protection. For fence posts and ground contact applications, soak the buried section in concentrated borax solution for 24 to 48 hours before installation. The extended soak allows deeper penetration. Borax has one limitation. It is water-soluble. In applications with constant water exposure, the borax can leach out over time. However, for fence posts, barn timbers, and protected structures, the borax remains effective for decades. Modern borax costs approximately $4 to $5 per pound. 1 pound treats several fence posts. The cost-effectiveness compared to commercial pressure treatment is remarkable. Results documented from the 1940s show 40 to 50 years of effective protection. Number 6. Pine tar, Stockholm tar. Scandinavian shipbuilders used pine tar for centuries before American farmers adopted it during wood preservation shortages. The technique protected Viking ships for ocean voyages. Protecting fence posts is considerably easier. Pine tar is distilled from pine roots and stumps. The resulting thick, black substance contains natural fungicides, water repellents, and preservative compounds. It smells distinctly of pine and smoke. That smell indicates the presence of protective compounds. The protection mechanism is comprehensive. Pine tar creates a water-impermeable surface layer. It contains natural phenolic compounds that are toxic to decay fungi. It remains slightly flexible, allowing wood to expand and contract without cracking the protective layer. Application from traditional methods involves warming the tar to improve flow. Apply with a brush to all surfaces, working the tar into cracks and end grain. 1 coat provides significant protection. 2 coats provide optimal results. Allow 48 to 72 hours of drying between coats. For ground contact applications, World War II-era farmers combined pine tar with linseed oil at a ratio of 1 part tar to 3 parts oil. This created a penetrating treatment that protected from the inside while the tar sealed the surface. Wooden structures in Scandinavia treated with pine tar have survived over 500 years. American fence posts from the 1940s treated with this method are documented surviving into the 2020s. Pine tar costs approximately $15 to $20 per gallon. 1 gallon treats numerous fence posts. Number 7. Salt treatment. Salt preservation is as old as human civilization. The same principle that preserves meat preserves wood. During World War II, when commercial preservatives were unavailable, farmers returned to this ancient method. Salt works through osmotic pressure. High salt concentrations create an environment that is hostile to fungi and insects. Organisms attempting to colonize salt treated would lose moisture through osmosis and die. The wood itself becomes inhospitable to decay. Traditional salt treatment involved soaking wood in concentrated brine solution. World War II-era methods called for approximately 2 pounds of salt per gallon of water heated to improve dissolution. Fence posts were soaked in this brine for 1 to 2 weeks before installation. A variation called the salt and baking soda treatment combined 1 pound salt with half a pound of baking soda per gallon. The baking soda raises pH and provides additional fungal resistance. Salt treatment has limitations. Salt is corrosive to metal fasteners. Salt-treated wood should not contact galvanized hardware without a barrier. In coastal areas with high humidity, salt-treated wood may absorb atmospheric moisture. However, for fence posts and non-structural applications, salt treatment provides remarkable longevity at minimal cost. Posts treated in the 1940s using this method have been documented surviving 40 to 50 years. The cost is negligible. A 50-pound bag of salt costs approximately $5 to $10 and treats dozens of posts. 7 methods. 7 techniques that World War II-era Americans used when the modern supply chain failed them. Charring linseed oil. Used motor oil, lime wash, borax, boin tar, salt treatment, each one proven over decades of actual use. The fence posts installed using these methods in the 1940s are still standing. The pressure-treated lumber installed in the 1990s is already being replaced. Modern wood preservation is designed to sell products. Traditional preservation was designed to solve problems permanently. The difference shows in longevity. You do not need expensive commercial treatments. You do not need specialized equipment. You need knowledge that hardware stores cannot sell you because it eliminates repeat customers. Try one method this season. Char your fence posts, brush them with linseed oil. See for yourself why these techniques survived when commercial products failed. 50 years from now, will your fence posts still be standing?